Hi everyone. Today we've been given a problem over here where we've been presented a diagram. And in this diagram we have a square, and inside that square we have a circle, and inside that circle we have another smaller square. So what we've been told to do is we have to find the ratio of the bigger square's area to the smaller square's area. So how do we do this? Well, before solving the question, I'd like you to go ahead and try solving this problem on your own. And then you can come back to the video where we'll discuss a step-by-step solution on how to solve it. So let's go ahead and get started. There are multiple and a couple ways to solve this problem. So if you solve it, you can go ahead and think about how you can solve it using a different method. So let's get started now. Over here, we have a square, and inside that square we have a circle, and inside that circle we have another square. So one thing we can say about this is that since they're squares, all four sides of them are equal. So we can go ahead and state that this, we can name this x. So the smaller square side is going to be x. Now, since this is a circle, we know a couple things. Since it's a circle, if I draw a chord that passes through the diameter, touching any 2 points on the circumference, all lines will all be equal. So that means if I draw a line from here to here, and this passes the diameter, then any other line which passes that diameter and touches 2 points on the circumference will be the same length. So we can also say that if I draw a line from here to here that passes through the diameter, then both of these lines will be the same length. So that means that if I name the side length of the larger square as y, so this will be y, then that means this would also be y. So that may seem like a lot to process, so before we actually dig deeper into that, let's go ahead and solve a couple other things first. Over here we have x, and x is the side length of the smaller square. Now, knowing that, we can tell a couple things. Using the Pythagorean theorem, which states that x squared plus y squared is equals to z squared, where x and y are both side lengths, and z is the hypotenuse. So over here, since it's a square, x and y are the same thing, meaning that we would have x squared plus x squared is equals to the hypotenuse, which is y. So that means we can tell that 2x squared is equals to y. And now we need to find, this is supposed to be y squared. So now we can tell that y is the square root of 2x squared, which is x root 2. So y is equals to x root 2. And now knowing this, we can also tell, we can state a couple other things. So that means since y is equals to x root 2, we can find out the area of the smaller square. So all we have to do is we have to simply square x. So x is, squared. So if we square x, we have x squared. So this is the area of the smaller square. But we need to write this in terms of y. But the problem is we can't do that. So instead of writing x in the terms of y, we're going to write y in the terms of x. Since we know what x is, what y is in terms of x, we're going to simply square y to give us y squared. And now since we know what y is in terms of x, we can simply substitute a y in terms of x and square that. So that means writing x root 2 instead of y, then we would have 2x squared. So that means that this is the area of the larger circle. The larger square. So there we have it. We have the area of the smaller square and the area of the bigger square in the same terms. So we can write that down. So since we need the ratio of the smaller square to the bigger square, we can write that down as 2x squared over x squared. And since x squared and x squared cancel out, we can write that down as 2. So 2 to 1. That means the smaller square is, the bigger square is double the smaller square. Now, as I said, there are a couple different ways to solve this question. So let's go ahead and try a different method to solving this question. So I'm going to go ahead and write this down as method 1, which is using algebra. So the first method, which we used, consists of algebra. Now the second method, which we're about to use, this is more graphical and using geometry. So that means more using pictorial representations. So to explain what I mean, I'm going to go ahead and paste our original figure over here. Now, looking at it, you can see that we have, as I said at the start of the video, it's a square, and inside that square we have a circle, and inside that circle we have another square. Now, if I moved the second square a tiny bit, and if I rotated it, then it would look like this. So now looking at that figure, you can easily come up with a couple things like we did using algebra. You can see that that over here, the hypotenuse is the same thing as the side length of the larger square. And then looking at that, you can come up with a couple other things, and you can move the smaller square a bit more to make things a bit more clear so that the square looks like this. So now over here things are way more clear because I've gotten rid of the circle. And the circle was pretty much a distraction, but it did help us realize a couple things. But now over here, since you can tell that half of the smaller circle is a quarter of the bigger circle. And you can tell that because over here, if I divided the bigger circle into 4 parts so that it looked like this, then half of the smaller circle takes up a quarter of the bigger circle. So 2 times half of the bigger circle, the smaller square, would give us half of the bigger square. And if that doesn't make sense, you'll understand seeing the next figure. In the end, the figure would look like this. And now you can clearly see that the square is equals to half of the bigger circle, the bigger square. So the smaller circle is exactly half of the bigger square. So we can write that down as 2 to 1 because the bigger square is exactly double of the smaller square, which is exactly what we came up with in the previous method. So, thank you for watching this video, and I hope that it helped. If you can think of any other methods to solve this question, be sure to let me know in the comments. If you like this video, be sure to check out our channel. We upload lots of similar content and we upload daily. So thanks for watching.